Okay. This is the start of our technician license study groups, and we're here at the clubhouse. It's Sunday, February 13th, 2022. So we'll go ahead and get started. Just wanted to start off by talking about some of the purposes of this study group approach, and one of them obviously is to help you pass the test. But the other thing we'd like to do is to give you some insights into all kinds of things you can do with ham radio, give you a little better technical understanding of ham radio, so that after you get your license, it'll be easier for you to start using some of this stuff. But it's really surprising how many different things you can do with ham radio. It's just not Morse code on a key in a shack somewhere or talking on a microphone. There's all kinds of digital stuff, satellites, bouncing signals off the moon, just high frequency stuff, microwave linkages and that kind of thing. So that's kind of what we want to do. And just give you a little bit of my background. Uh, my call sign's K3SKS, and I got my first ham license. I think it was March 2017. That's when the 10 of us took the test together. And then a couple months later, well, I got the technician, the general on the first testing, and then extra a little bit later in June of 2017. And it was fairly easy, the technical stuff for me, because I've got a degree in electrical engineering, and all that stuff was fortunately, I can remember stuff I learned 40 years ago better than I can learn what I learned yesterday, I guess. So that's kind of my background. Jim is our oldest licensed ham. That he, when did you get your first license? Back in the 50s. 57. I was 5 years old, Jim. 1957? Well, you were about close to my age. Yeah. We're a little over 5. Yeah. So I think my mom was 1. Yeah. So and now he's an extra class licensee as well, and it's funny. Everybody's got kind of a little different niche they like playing around with in ham radio. So you'll find a niche. So let's see if I can move this thing along here. First thing you need to do if you is to get an FRN number from the FCC. Now, what I'll do is after this session, I'll email you all these slides, so you don't need to take copious notes or anything. Yeah, so this is the address is down here in the PDF file. You should be able to just click this, and it'll take you to this page and go through the process. And the reason for that is that you can no longer use your social security number to take the ham test. They'll want your FRN number, so it's more secure for your protects your social security number. And about halfway through this sequence, about chapter 5 or 6, I'll remind everybody, to ask them if they've had their FRN number yet. But it's real easy. And then what'll happen is that'll be the number you use on test day. And if you go to the FCC to check your license or get a vanity license or whatever, you use that FRN number. So it's something you want to save. And it should work out pretty well. Or if you want to get a vanity um, call sign, you need your FRN number. So that's just if you do it tonight before you go to bed, you'll be in good shape. All right. And then just a little bit about our group. We're not an official club. We call ourselves a group because we don't have an organization or a constitution and bylaws. Um, we don't have officers, but our main mission is our purpose is to develop and operate a power grid, internet, and phones down emergency communication system using amateur radio technology for our community and the surrounding area. So our focus is on Treasure Lake and Du Bois. We go out to Rockton. That's kind of the area we wanted to be able to communicate within. So if something happens locally, we can be in touch with it. And then we also, and I'll get into that at the end of this chapter, are set up so we can communicate with the outside world too. And I'll get into that a little bit. And just to show you, this is Judy and my shack. It's in our office down in the lower level of our house. And I've got two computers. This one here, for example, is my personal computer. I primarily don't use it for ham stuff, but do occasionally. And then these two monitors are all tied into my ham equipment. And this is an HF transceiver. This is a scanner. Are you able to see? I don't think. Oh, the mouse isn't working. Okay, let me try this. Pointer options. Okay, laser pointer. There we go. Okay, so this is my personal computer here. Okay, good. These two screens are tied to the ham computer, and that's where we do all the ham stuff. And there is a lot of stuff you do use it or can do. You don't have to, but just various areas you can play around with that you can use a computer to do some pretty neat stuff. Here's the main HF rig. That would be for 6 meters to 160 meter operation, and we'll get into what that means a little later. Here's my scanner. This is the VHF UHF radio for local communication, and this is a weather station I have. My handhelds are up here, always being charged. These are the books and things that have what I don't know in them, so I can get to them quickly. Here's a right here. It's kind of hard to see. This is a power meter, an SWR meter for both the HF and the VHF UHF radios, and then an antenna switch. And that's about it. One thing that may not be readily apparent that's nice about this setup is that this is the lower level of the house, but it's a walkout basement, so these windows are outside. And what that enables me to do in order to connect the antennas and things in the back, I just go outside, open the window, and do the connection. It's real easy. If I had to kind of squeeze back there and try to do it, it'd be a problem. The other thing I have that's handy is in this window down at the bottom. You can't see it, but it's an antenna pass-through. And what it has is just a aluminum or stainless steel plate on a board that you close down the window on top of it to secure it, and then you bring the window to the outside plug, and then inside you put another cable on and go to the radio, so you don't have to poke holes in the house. Judy was not going to be happy if I had to drill holes in the house.
I was going to ask you, for example, in my basement, it's under.
Yeah.
But you know where everything that comes like the cable, internet, it all comes through, the outside into the basement.
Mm-hmm.
So maybe can I drill through that and put that cable to an antenna? I just bought the lot next door because I guess I didn't pay the taxes, so I bid on it last week. So then it's full of trees. So maybe I could put my antenna.
Yeah. A lot of people do that. No, it does somewhat. We'll get into that in the general study. You get line loss. The longer the line is, the more loss you have. But it's not going to be a big.
It wouldn't be too. I put the antenna, like you guys said, in one of the trees. There's a lot of trees. There's like a huge maple tree right next to the lot.
Yeah.
I was going to have somebody trim it down, and then they put it up there, and then it'll come down right into the basement, and then my equipment is would be right where it comes in.
Yeah, that's good. You start thinking about that now, and this kind of helps get you in that thought process. But every shack's different, because they're all different situations. So that's what we use, and it's worked out pretty well. Let's see. And then this is just the schedule for these sessions. We're going to do chapter 1 and 2 because there's really not too much in chapter 1. But this is in the PDF file that went out when we started promoting this class. Now, the FCC testing topics, obviously, this is the book that we're using now, the new fourth edition, and it's good through June 30th of 2022. So after June 30th, there'll be a new set of tests and there'll be a new manual. So we'll want to get the test, which shouldn't be a problem. We'll get the test done. We'll probably be doing it in April, unless since there's just one of you, we could shorten that if you want. We could do a couple sessions a week, and you could be ready for it in 4 weeks. I mean, it's up to you.
I mean, I'm good.
So I remember before I got interested in ham radio, I'd find these ham radio tests online, and I would take them, and I wasn't passing, and it used to just irritate the heck out of me because I thought, I know this technical stuff, but what the test covers, and these are my numbers, just kind of what I've gauged things on. About 60% of the tests are technical subjects, and then about 30% are operating practices, how you do different things, whether it's a single sideband or CW or a digital mode, how do you do things? And then about 10% of the questions are laws and regulations. So what was happening to me, I was doing pretty well here on these 60%, but you need 75%, I think it is, to pass. So I didn't know any of this stuff, and that's what we got into when we started doing these sessions. So the details on how they make up the test, on both the technician and the general, they have 35 questions on each test from a pool of about 350 questions. And you need 75% score to pass, or 26 out of 35. And there's multiple tests available. When you go to wherever we have the test, they'll have a stack of different tests for technician, and they will have different questions on them. There may be 10 different test formats. But they all follow the technician class syllabus. And what that is here, these are the different sub-elements from the test pool. And using the same colors I used on that graph, the blue ones are technical. So there's a group here, radio wave characteristics. There's going to be 3 exam questions from 3 groups on that, regardless of what test they give you. There'll be different questions. So that, this one, electrical components, modulation modes, antennas and feed lines, but they all have the same number of exam questions from that group. So each test, there's no way of getting a lucky test that you only get one section of questions. And then this sub-element here, T1, deals with the rules and regulations from the FCC. And then the green ones, the 30%, are the operating procedures. So each test will have 3 exam questions from this sub-element, and they'll have 2 from this sub-element, but there'll be different questions on different tests. So not that that's a problem, but I've heard people think or mention, they think, well, maybe I'll get lucky and have nothing but these kind of questions on here. Well, that's not going to happen. They've got that structured pretty well. Yeah. So you need to know fairly broad understanding of, which isn't all bad. So what our recommended study approach is that before we have the study group, you read the chapter, work the chapter pool questions, and then come here. And what we'll try to do is try to explain maybe a little differently or from a little different perspective, whatever the chapter covers, to help you understand it better. And then when you're done with the study group, you can go to this website, hamstudy.org, and there are tons of websites for studying for ham tests. But this one we've used, and it's done particularly well for us. I know Judah used it, and it has a flashcard feature where it'll ask you a question and you answer it. And if you miss it, it'll ask you the same question 3 or 4 or 5 cards later. So it reinforces the things you miss. And then there are also practice tests on this hamstudy.org. And and what that is, it would be an FCC type test with the same breakdown as the FCC test, and you take it. Excuse me. And what we recommend is starting with about chapter 5, begin taking the practice test. So you start taking it, you're not going to pass because you're only about halfway through. But what you'll see is that each week your score is going to get better, and that'll help build your confidence that you're not going to have trouble with the final test. So that seems to work out pretty well. And this is the HamStudy website technician class. You can set up the study mode. You have to log in, create an account. It's free. They do give you the opportunity to make a donation if you want to at some point, but it's not at all required. So that's one we recommend. You may find one you like better, which is fine.
Is that the HamStudy?
Yeah, HamStudy.
Yeah. The one that you.
Yeah, it's either .com or .org. You can just Google HamStudy, all one word, and this should pop up. So the videos or these study classes, the reason I started putting the videos together is because when we started, we'd have maybe 4 to 6 people in each study group, and that gets to be that. I mean, that's good. That's we were generating a lot of hams that way, but I think we've reached the point where we've kind of depleted those that are interested in ham radio. So now we just get an occasional 1 or 2. So I thought it'd be good to capture these study groups on video, so that if only one person was interested, uh, we could direct them to those study group videos, and they could hear the same thing that you would hear sitting here. So that's why I'm recording this one. So really, there's 2 purposes. Obviously, like I said, help you pass the test and provide understanding of how things work for after you get your license. And I've done a lot of teaching. I mean, I worked in manufacturing and managed companies all my career, but I like to teach, and at nights I would teach at different colleges. And I would sometimes I teach technical courses, sometimes I teach business courses. But I always thought this is what the objective of a teacher should be. If you can't explain it simply, you don't understand it well enough. And so my first objective is not to confuse you. You know, whether you learn something or not, that's a different issue, but I certainly shouldn't confuse you. And if I'm not explaining something very well, let me know and I'll figure it out and try to do a better job doing it. So after the video or the study group session, you won't have to send me the email, but say if you were taking the videos, maybe you'll do that for your general. Just email me that you finished it, and I'll email you a PDF file of the slides that we're covering, and then the PDF of the chapter questions. And the way the PDF file set up, if there's a hyperlink, and you're connected to the internet on your computer, you can just click the hyperlink and it'll take you there. So these are 2 links. This is the hamstudy.org link we talked about. And then there's another fella, Dave Kassler, KE3OG, I think it is, that has a real good series on videos for the technician class, the general class, the extra class. That would be another place to go. In fact, you may be better off watching them than our videos. I don't know, but we've had good success. I kind of like to keep it local if we can. But he is one source that I would recommend to check. And he not only does the testing videos for each radio class, he does a lot of other, when you start getting into different parts, say antennas or whatever, he has good videos. Say if you're interested in an in-fed half-wave antenna, well, he's got a video that'll explain it. So he's a real good source for that kind of stuff. He's an old man with gray hair and a beard. So, and then chapter 1 was just a welcome to amateur radio. They talk about what makes it unique, why the FCC makes the rules. Now, in ham radio, there's laws and regulations set up by the FCC, and those are, you have to follow them. People go to jail if you don't, if you abuse the rules. Then there's another set of, I don't know if I call them regulations, but they're generally accepted practices. And it's pretty much self-policed by the hams. It's kind of developed over the years a consensus, and one part of it is what part of the band is used for what. For example, on 40 meters, which would be 7 to 7.3 megahertz, there's a generally accepted practice that from 7 to 7.125 is Morse code and digital. So that's the part of the band you would normally use for that. And then 7.125 is the start of the single sideband, and it runs for extras from 7.125 to 7.3. And then the generals, they can all use part of that band. That runs from 7.175 to 7.3. Now, the fact that those limits are there on the frequencies, that's an FCC rule.
So
if you go over, if you're a general and you get in that extra band, I can assure you some ham's going to tell you, because as soon as they hear, a lot of guys, as soon as they hear a call sign, they'll type it into the database and see who it is. And I've heard several people that have tried to call CQ in that band, and then somebody would come back to them and say, "Hey, you're a general. Get back at the general band." So, but that's the difference between the rules, the laws and regulations the FCC does, and the generally accepted practices. Technically, you could operate CW anywhere, but it's not agreed to. As long as you're in the band that you want to, that your license allows you to be there. Talk a little bit about the technician license and what that'll do for you. So the test or the license structure for the ham radio by the FCC has 3 levels of license, and they refer to, well, the first level is technician, which is the one you're going for now. It's referred to as exam element 2, and then the other ones are 3 and 4. And the reason it's exam element 2 is that there used to be a CW requirement, but they did away with that. So rather than renumbering them, they just did away with exam element 1. And to get your technician license, you have to satisfy the requirements for 2. Now, to get a general, you have to already be a technician. So you have to have this as kind of a prerequisite, and then you can take the general test. Now, you can do that on the same day, because as soon as you take the technician test and pass, and the VE hams sign off on your form that we'll go over, then you're technically a technician, and then you're eligible to take the general if you want to. So you could take all 3 tests in one day if you want to.
But wouldn't there be more information that I need to know for that general?
Yeah, there's another book just like that for general, and a thicker one for extra.
I could try and see.
Well, yeah, you could try. But keep in mind, well, I know I took the technician and general the same day, but the reason I didn't try all 3 is we only had 4 weeks. We decided on week 1 that we were going to do this as a group, and then we were going to take the test 4 weeks after. So I only had enough time to really study both the technician and general. And the other thing I wanted to do was study the extra so that I would understand better when I set up my shack. I didn't want to spend the money on bringing in radio equipment until I felt I was comfortable doing it. So the number of questions for technicians general, like I mentioned, are 35, and you have to get 26 right. The amateur extra is 50 questions, and you need 37 correct. So with the technician license, you'll be able to use all VHF and UHF bands that are allocated to ham radio, and some HF privileges. In 10 meters, for example, there's a section that you can use as a technician for single sideband, and then there's you can use CW and digital modes on 10 meters, and I think 6 too. I may be wrong on that. And then with general, you get all the VHF and UHF privileges and most of the HF privileges. There'll be a segment in each band that's reserved for extra licenses. You can't use that, but actually most everything that goes on, like contests and nets and things like that, are held in the general band because that more people can do things there. So it's I don't know, Jim, but I haven't found anything that was an advantage to having the extra. I mean, I can do everything. Well, it does help with foreign countries because each country has their own frequency rules.
A lot of Jones up there trying to talk to a foreign country.
Yeah.
And then you might have hard time getting into down the amateur part of the band, but foreign countries calling down there, Paxton thinned out.
Yeah, and I think I think Canada, their main equivalent of general band includes the extra band here, so they're offset a little bit. So there are some Canadians you can't contact unless you've got your extra license.
Yeah, so various countries seem to have a little bit different areas.
Yeah.
Operating.
Yeah.
So you just only talk to them basically.
And the other thing you'll find out, for example, on 40 meters, since every country allocates their frequencies differently, in the evening, about 7 o'clock, there are AM radio stations from the Middle East that broadcast in the center, the 70-meter band.
Oh,
and
really?
you can see them on the band scope. Yeah, and it's all this Iranian music and that kind of stuff.
Do they do the call to prayer?
I haven't heard that, but they pop
I
up.
live in Nowhere, so I
Oh, okay.
7 times a day.
That'll happen. So it's kind of interesting how it all works. Then the section here on what makes amateur radio different. And we kind of went through this. This is what we evaluated when we were trying to find the right technology to use. And for example, the Citizens Band radio has 40 channels, a range of 10 or so miles, depending on terrain, and intended use is private or business. Marine VHF obviously is intended for maritime use, 50 channels and 20 or so miles range there. Family radio service. I bought a set of these when I visited the grandkids. They've got what are they? 7, 8, 9, and 10, and they had a ball with those things. But you don't need any license for them, and you can go 2 miles if the terrain's right. Terrain around here, it's just pretty much going to be line of sight, so that wasn't really useful. And then MERS, multi-use radio service, has 5 channels, no testing required, no license. And it being VHF, you can get up to 5 miles there. Now, ham radio has a capability. Well, yeah, thousands of miles, even on VHF. We have a VHF, we have a UHF repeater here, and I'll explain what a repeater is in the next chapter. You probably already know, but we have one at the church, and it gives us the ability to cover most of Treasure Lake. It's a 40-watt repeater. It's not particularly powerful, nor is it the antenna high.
About 10 miles around.
Yeah, it's sufficient to do what our mission is. So we have that. There are a lot of repeaters in the area that have tremendous range. There's one in Clearfield, for example, that covers all the way over to the I-79, I-80 interchange, and then just about as far to the east, not quite as far to the north because the terrain picks up north of us, and then down south it can get down into Altoona. I mean, that would have been a repeater we could have used, but we didn't have control over it. You know,
Somebody else,
yeah, it's somebody else's repeater, and for emergency,
they might push you off the thing.
right, they could set it up so only their members could use that repeater. And so we wanted to be able to be absolutely certain we could operate our repeater, you know, in any conditions. And it's set up for about a 7-day battery backup. We figure one of us could get up there once a week to swap batteries out. So that's about it for this chapter. Just a reminder, hamstudy.org, that's another link to it. So do you have any questions on any of that? Not a lot of meat there, but it's good to kind of understand this stuff. So I'm going to stop this now. Okay, this will be chapter 2, radios and signals fundamentals. So what we're going to start looking at here is the radio spectrum, and start to get a little understanding about electromagnetic waves, how we're going to use those to transmit information. Talk a little bit about basic types of radio equipment and simple radio stations. They started off with a table here showing the prefix for numbers. And what it is they're like, for example, probably the 4 most common ones you'll encounter as a ham will be mega and kilo, which are mega is a million. So if somebody says 7 megahertz, and hertz a cycle per second, then they're talking about 7 million cycles per second. If they're talking about a kilohertz, they say the bandwidth is 3 kilohertz, that means that the width of the signal and the frequency spectrum is 3 kilohertz wide, or 3,000 hertz wide. And then for each decade, it starts off at tera, which is 10 to the 12th. So a terabyte or a terabit drive, for example, on a hard drive would be one with, that would be 1,000 billion bytes or bits or whatever they're talking about. It's just a prefix that scales the number. Gigabits is 10 to the 9th, or that would be a billion. Mega is 10 to the 6th, or a million. So if you had a megabuck, you've got $1 million. A kilo is 1,000. So somebody talks about a $4 kilo, that's $4,000. And then so you get down to the fractions, and it starts with deci, which is 1/10. So if somebody talks about a decimeter, that would be 1/10 of a meter. Then cent is 100th. So you hear references to centimeters. That means it's 100th of a meter. And then the two that you'll run into more frequently, particularly in component sizing, are milli, which would be 1,000th of whatever the unit is. It could be a milli ohm, I guess, or micro would be 1/1,000,000th, or 10 to the -6. A microfarad would be 1/1,000,000th of a farad. So those are just prefixes that describe magnitudes of numbers. And it'll come, I mean, if you're not familiar with these prefixes, it'll come to you as you go along, because they'll be using these to describe different things. Now for the amateur radio technician privileges, these are the different bands, and they express the bands in terms of wavelength. For example, here, UHF, ultra high frequency, is 23 centimeters. And what that means is that the frequencies in the 23 centimeter band run about, I think that's a hard number to see, 1240 megahertz to looks like 1300 megahertz. And then there's a 33 centimeter band and a 70 centimeter band. And then, so that's the UHF frequency bands. Then the lower frequencies, the longer wavelength ones, are 1.25 meters, which is about 220 megahertz, 2 meters, which is about above 144 megahertz, and then 6 meters. These are considered VHF bands. And I've got the next slide or so will show how all these fit together. Probably should have put that one in first. And then down here, HF runs from about 10 meters to it's actually 160 meters. It's not shown on the graph, but 10 meters, for example, is from 28.5 and to 29.7 megahertz. So those are the frequency ranges for 10 meters.
So for example, just a quick question.
Sure.
On the HF, right, it says 10 meters.
Mm-hmm.
So I could go if I'm on my radio, I can transmit from the frequency, I really can't see it from here, but
right here.
From there, all the way to there.
Right.
Okay, and then whatever's graded out can.
Right. You can listen.
Yeah.
Anybody can listen. You need the license to transmit. Yeah. And we do some things on 10 meters, and we do it in our nets and practice in this frequency range so a technician can participate.
Yeah.
And it's part of our emergency setup. If we're going to do anything on 10 meters, it's going to be in that spot so that anybody that has the equipment and at least a technician license can participate. The primary frequencies you'll be interested in as a technician will probably be 70 centimeters and 2 meters. These are the dominant bands for repeaters in the area, or handhelds. A lot of handhelds and a lot of radios for VHF and UHF can either be UHF or VHF, or it could be UHF and VHF. So if you're looking for these radios, you can do both UHF and VHF. So that'll be good. Now our repeater is on the 70 centimeter band. And the frequency for that is 442.525. So it's up in here somewhere. The other repeater we use out of Clearfield, that big one, is 2 meter repeater, and I think it's I don't know what it is, 145.255 or something like that. But when you program the radios, you can attach names to the frequencies if you want to. So those are the two primary bands that we deal with with the technician license.
The way 10 meters is, it's getting better typically. Not even a year or two.
Mm-hmm.
Still a technician. You can probably talk to lots of places before 10 meters.
Yeah, you would need obviously a 10 meter antenna and a single sideband radio that would be for 10 meters.
Yeah.
And we'll get into the differences, but these two bands, 70 and 2 meters, typically operate FM, frequency modulated mode. And then typically in the HF, we operate single sideband, and we'll explain that when we get into the different types of modes. They both have pluses and minuses. FM typically has better audio qualities than single sideband. Single sideband has better propagation because of those frequency bands. You're using the ionosphere for your signal to bounce around. So that's why you need both.
So another question. So for example, as a technician, I could talk to other technicians in that frequency range that I am allowed to be.
Right.
Talk to even generals about
Yeah, you generals and extras will be in there too,
But
right?
but what I'm saying is, what about like depending? I can talk to someone that is in Spain. That's a technician.
it. If they had somebody in Spain, you hearing somebody that's Spanish, you'd be allowed to talk to them. You're allowed to translate. You're allowed to listen.
Yeah, but with the practical nature of the VHF, UHF bands, for example, you're not going to have the range with that mode, with the FM mode. So there are.
I'd like to talk about 10 meters.
Oh, I think you were talking about the handhelds, or
No. So, for example, as anything, you know the setup you have.
yeah,
Let's just say, can you pick up someone from Spain?
yeah,
If you had, okay. So if I was a technician
On 10 meters.
on 10 meters and I had that same setup, I can talk to someone in Spain who is a technician or a
Well,
general
that's
that's on that same 10 meters,
you're right,
right? Okay.
right.
Yeah, my was class, if you're allowed to translate there, you're allowed to listen
Yes. As long as I'm within the band that I'm allowed.
Right, right.
It doesn't matter who I'm talking to. If I go over, then,
there. But they
I'm
try to
not breaking the rules.
Yeah, right.
Okay, I got you.
So I talk to lots of people, 10 meters, better offers, about every month. They got a sunspot cycle.
All right.
That's
Yeah,
there's one way after the
the HF bands are very dependent upon the solar characteristics that are putting energy into the ionosphere. And our sun, actually, about the time we got our license, we were at a solar minimum. So it was about as dead as you could be. And since then, the sun cycle, which is about 11-year cycle, has been increasing. So the propagation's getting better. And probably in a year or two, it'll be extremely good.
2 more years, probably.
Oops. What am I doing here? Can't get my mouse to move. Oh, there it is. Okay. I'm kind of a history buff, particularly science history. So I like to mention a couple of guys here. Maxwell, he was alive from 1831 to 1879. You may hear, particularly as you get in the general and certainly the extra study, reference to Maxwell's equations. And what happened is that back in the mid 1800s, he was able to theoretically describe, he didn't actually do the work, he recognized that there were 4 equations that other people had developed that can be used to describe how electromagnetic waves operate, that they existed, and it was kind of a real major breakthrough for electrical things, because at least theoretically at that point they understood how things were supposed to work. They haven't proved it. They didn't prove it at that point. It was just a theory. So then, guy Heinrich Hertz came along, and I'm not sure exactly when, but he was 1857 to 1894, so probably late 1800s is when he measured and demonstrated that the theory on electromagnetic waves was indeed true, and he was able to prove it. And that's why when his name now is used to describe cycles per second. So it used to be talked about power at 60 cycles per second, and then at some point, I think it was even before I got into college, if not earlier, they changed cycles per second to hertz. So you'll hear 60 hertz. That's what our power is. Or you'll hear 7 megahertz. This is the guy that they've named it.
Cycles per second.
Yeah, you can tell really old ham when they get on the air with cycles per second. You still don't use cycles per second, do you?
I get it. Hertz.
Oh, okay.
I prefer to 60 hertz. I might say 60 cycles.
Yeah.
I've heard that for a period of at least 5 or 6 years.
Yeah.
50 or 60 years. I've heard that before. The cycles per second.
But at some point in here, we're going to get into electromagnetic waves, how they function, and what they do. And these are the guys that were critical to their understanding. So the best way, I found this video that talks about waves, and the waves operate the same whether it's waves on a pond or electromagnetic waves or air waves. So when you get a chance, you could watch this video, and what you'll see, for example, they'll have this type of wave pattern where they're putting drips into a pond and the waves move out. And if you look at the cross section of that, it looks like a sine wave as it goes out. That's exactly the way the electromagnetic waves propagate from a vertical antenna. So when you start thinking about antennas, you can think of it in terms of those waves coming off the antenna element and what do they do from there. And so if you can conceptually see it with a water wave, then it helps for your mind to think about it, because you can't see the electromagnetic waves, but it'll explain it to you. It just helps you see it a little bit better. Antennas are probably the most important topic in ham radio. They have the most impact on how well a station performs. So the better you understand antennas, what they can and can't do, then the better station you can put together. So this just kind of gets you started into the wave thinking. So on a wave, sine wave, for example, this is figure 2.1. Just some points of reference. You talk about a sine wave, it'll go positive. Then at some maximum point, it'll start decreasing the intensity, and then it'll go negative, and then back positive again. And this complete trip from 0 to 0 is called one cycle. So if we're talking about 7 megahertz, that means this cycle happens 7 million times a second.
A second?
A second, yeah. And if it's 442 megahertz, then it's 442 million times per second at that frequency. The higher the frequency, it's moving.
Yeah.
So this is this whole cycle is referred to as one period. You know, if they talk about a period of a sine wave, that's what one cycle is. And it's typically represented by the variable t, and then this is time on this axis. So there to here, here to here would be 2 cycles or 2 periods. Now the frequency here for one cycle is 1 over the time, because it's cycles per second. So if this is 1 second, then this sine wave would have a frequency of 1 hertz, because it's changing 1 time a second. Then there are what's called harmonics of a signal that are of interest, where if you have a frequency, whatever the frequency might be, then the second harmonic is 2 times that frequency. So you can see the frequency here, we're going 2 cycles in the time of 1 cycle of the fundamental. So there's the fundamental frequency, there's a second harmonic, and then the third harmonic would be 3 times the frequency. Now, where that's important is actually these radios here, the Baofengs, aren't legal in the U.S. because of the harmonics. And what happens is they're set, I don't know, these may be, I haven't checked these. But what happens is if you have a cheaply designed oscillator. It'll generate a fundamental frequency, and that's your transmit frequency. We'll get into this later. But what happens is if it's distorted because of the oscillator, then it'll generate harmonics at higher frequencies, and that is noise. So that it's something that the FCC watches and checks in order to approve a radio for sale as a ham radio, that the harmonics are lower in magnitude, low enough in magnitude that they don't interfere with other parts of the frequency spectrum. Because if you look at the whole frequency spectrum, it's huge. And ham radio is just a little slice of it. You get different sections of it. But what you don't want to have happen is somebody operating a ham band interfering with a police band, or
So those can, and
those can interfere. And that's why the FCC tests those things. Some of them are okay, some of them aren't. It'll say whether it's FCC approved or not. And then here's another video that I thought was pretty good when that explains the electromagnetic spectrum. If I find a video that can explain something better than I can in a quicker time, I like to use those. The problem with finding good YouTube videos is you have to watch a lot of bad ones to find
yeah,
them.
to find a good
So on your PDF file, you have a little time, you could click this YouTube video and we'll get in the electromagnetic spectrum. Now, the thing about the electromagnetic spectrum that is of interest to ham radio is that if we look at it in terms of frequency, we could say it starts here at 3 kilohertz and goes to 30 kilohertz, and that's referred to as very low frequency. And then you can see these are increased by factors of 10. So we go from 3 to 30. That's very low frequency. You don't have to remember these, but you'll get to the point where you'll know HF, VHF, and UHF after you use it for a little bit. So then 30 to 300 kilohertz is low frequency. And then we go from 30 kilohertz to 3 megahertz, which is 300 times 10. And that's medium frequency. And that's where the AM stations are on your radio in your car. And then HF goes from 3 megahertz to 30 megahertz. And that's where the shortwave listening is. And the part of that HF band is parts of it are for ham radio. So the parts that are for ham radio would be not 1.8 is the first one, but it's that would be in the medium frequency. But the HF starts at 3 megahertz, and then that's the 80 meter band. Then it goes to 60 megahertz, and that's an unusual band.
I was gonna say, I didn't see it.
Yeah, that'll be more in the general, but most of the long distance bands for ham radio operate in this range here.
Yeah, 30 or 30.
Yeah. And then you go above 30 megahertz and you get into what's called very high frequency, or VHF. And that's where our part of the band is for VHF FM and TV, FM radios. They're all in there. And then you go to the next decade of ultra high frequency, UHF TV, mobile phones are in there, and our UHF bands are in there. You
There's
also,
something higher than
yeah, oh yeah, there's a super high frequency and extra high frequency. And for hams, this is a lot of it's just experimental. There aren't a lot of guys doing common everyday ham. There's one mode that I'm interested in, and I know Mike Smith is. where you use microwaves to interconnect computers instead of using the internet. That way, if the internet's down, you can still build a network of computers tied together. And that'd be kind of fun to play with.
That'll be cool. Once I get my technician license.
Yeah,
And
yeah.
I understand.
Yeah, you'll have privileges in these
Yeah,
bands
when
in.
things come up.
So that's how the continuous spectrum is kind of divvied up and what's in each band. Now, the relationship between wavelength and frequency is pretty easy to calculate. We use wavelength and frequency interchangeably when we talk about the bands. We can either say 40 meters or we can say 7 megahertz or 7.2 megahertz. They're both describing the same part of the spectrum. So that if you know the frequency and you want to know the wavelength, you just divide the frequency in megahertz into 300.
So, you know where it says in meters?
Right, that would
What's
be
in
the,
front of that?
yeah, that's that's a Greek letter lambda. That's what's used to designate wavelength.
Okay.
So the wavelength, if you know the frequency, if you take 300 divided by 7 megahertz, it should come out to about 40 meters. So in that too, as you get into it and start using it, even Judy knows. If I say 20 meters, she knows that that's 14 megahertz. I mean, it's just something you pick up as you go along.
Yeah, 6 meters, 50 megahertz.
Right. And then 10 meters is 28 megahertz. So this just describes that relationship. Now, the reason this works is this 300 is a measure of the speed of light, which is constant. It's always the same.
308 meters per second.
300 times 10 to the 8th meters per second, I think.
Yeah, well, 3 times 10, that's 300 million.
Yeah, right. That would be,
300.
I don't know. I'd have to look it
300
up.
ends with the 6. If you say 3 to the 8th, then be then
Yeah, this would have to be 300 million. I don't know. I'd hate to say, I'm not supposed to confuse anybody. I'd rather say I don't know.
300 million meters per second.
The way I remember it, I'm an American engineer. It's 186,000 miles per second. That's the imperial units.
And then you can change it and multiply it.
That's right. I can.
That's how fast the electricity.
Yeah, 186,000 miles per second. I remember that from a kid for some reason. And I can convert everything I know in imperial units to metric, but to me, I don't know.
Yes.
Kilometer, I mean, that doesn't have the same feeling as a mile, in my opinion. And then this is just another look at wavelength, frequency, and propagation. So you can think of that wave, for example, coming off of an antenna, and it's moving away from that antenna in some sort of sinusoidal pattern. And then the distance the wave travels during one cycle is lambda. And then this is just a re-expression of those two formulas we looked at on the previous slide. Oh, here it is. Speed of light, C is 3 times 10 to the 8th meters per second.
Yeah.
So that would be 300 million. Yeah, okay. I don't remember things I can look up.
Well, you have to remember 1,620 meters per mile. You don't have to do that very often.
So
Well,
there's some questions here.
yeah, we'll get into those.
Okay.
We have a question session after that. Come on, computer. Oh, there we go.
Oh, I see.
Then this is a screenshot out of the manual showing how on a frequency spectrum, where the frequency is the horizontal part of the line, or the horizontal axis, and the signal strength is the vertical axis. This is what a series of AM radio stations would look like on a frequency meter or frequency spectrum. So you have a signal here that's at 570 kilohertz. That's the AM number. So if it was an AM commercial radio station, it'd be known as 570 AM. 800 kilohertz is showing a stronger signal at a little higher frequency. And then 1,000 kilohertz. And between each of these signals, there's noise. So that's why when you tune your dial on AM, you'll not hear anything but static. And then as the it's actually the tuner's an actual band filter that's a certain width. And as you move that band filter, say it's the width of this red dot, you wouldn't hear the radio station there. As you turn the knob and the band filter starts moving this way, you start to hear it. And then when you get right on the center frequency, you hear it. That's the best signal. Then as you dial up, you start to lose it, and then you completely lose it, and then go into the next signal. So that's just by adjusting the frequency, that little window, you can tune to different radio stations. Now there's the idea of a transceiver. In the olden days, back in the early 1900s, when and I think even into the 50s and 60s it was this way. Typically a ham had at least two boxes on his bench. He had a transmitter that sent the signal to the antenna, and he had a receiver that would receive the signal from the antenna. And then there was a logic circuit of some type that would switch depending on, say, for example, if you press the talk button on the microphone, it would switch the transmitter to the antenna so that the signal could be transmitted. And when you release the switch, it would switch the antenna to the receiver so you could hear. And so that was a transmitter and a receiver. Well, most of the setups today are referred to as transceivers, excuse me, because it has all three functions in one box.
I used to have one of those few boxes.
Yeah. And just as you start looking through ham magazines and ham catalogs, kind of give you an idea of what you're looking at, your typical VHF, UHF transceiver will look something like this. They're generally made to be mobile, or you can use them as a base unit. I probably don't remember the picture of my shack, but it was the little radio up in the top right-hand corner. It's just about that big. Here's another example. And also the handhelds are typically VHF, UHF radios, transceivers, I should say.
So tubes about as big as the handheld.
Yeah.
I said three of them.
Well, there's still tubes in a lot of these amplifiers. People prefer them.
They probably don't exact prices.
No. Well, the HF.
Overlay doesn't kill them all.
Yeah.
No matter milliseconds.
The HF transceivers typically look like this. They're a little more complicated, more complex front panel. Notice a large dial that tunes the frequencies. That's kind of a typical characteristic. They either have a digital display showing the frequency or a little LCD display. But these are generally the HF type transceivers that you might see. Although I know ICOM has an HF transceiver that looks very similar to their VHF, UHF transceiver that looks very similar to their HF transceiver. I mean, I'm sure the logic and stuff and the radios are very similar, but it's used for VHF and UHF, both FM and single sideband. So there are exceptions. There's no hard, fast rules on these, but generally you'll be able to tell just by looking at it what kind of transceiver it is. Now, there's a couple different ways to operate the communications between two radios. The basic one is called simplex, and what that is it's a way of transmitting and receiving the signals on the same frequency. So if you're operating on 146.520 megahertz, which is a simplex agreed to calling frequency, and somebody else is on it, if you call, they'll hear you on that frequency, and then when they call, you'll hear them on that frequency. So that's referred to as simplex. And then there's another approach, could be referred to as a duplex as opposed to simplex, or a repeater operation. And what it does is, with the repeater, the advantage of that is if a guy on a handheld is transmitting, say, on 147.720 megahertz, the repeater will take his signal and instantaneously repeat it and start sending it on a different frequency. This is 600 hertz lower because you're transmitting on 147.720 megahertz, and then it shifts it down so that this guy hears it on 147.120. So they're both transmitting on the higher one and receiving on a lower one. And the other advantage of this repeater is by getting it high and by adding an amplifier, you can get much greater distances and be able to talk to someone on the other side of a hill. And that's the whole purpose of the repeater. And this is how our repeater works here in Treasure Lake. It's I don't know, the church is about 2 stories high. We're above the roof of the church a little bit. And then if you go to the other repeater I was talking about, the VHF repeater in Clearfield, it's on, you know, that point on Interstate 80 where it says it's the highest point east of the Mississippi. That and several other, a lot of antenna towers are up there, but that repeater is up on that point.
Rockton Mountain?
Yeah, Rockton Mountain. I don't know how high it is. It's several hundred feet up, and it's probably 1,500 watts, and that's why it can cover.
It's got good line of sight.
Yeah, it's really in a good spot. So.
You're on top of that target handheld, it probably works pretty well.
Yeah. You could work with a handheld here. You could work someone if the repeater's covering, say, Altoona. You could talk to Altoona.
The
guy in Altoona.
My handheld, I talked to somebody over in England.
Well, yeah, that's another thing. Yeah, they can take the repeaters and tie them to the internet, so that even with your handheld, and there are a lot of different ways of doing this. We'll get into those later. You can talk to anybody in the world that's on the same type of system as you, just with a handheld. Yeah. So that's one of the first modes I set up for Judy when she got her technician license. I don't like talking on the radio. Judy loves it. So I use what's called D-Star, which is one of several modes of tying your handheld to the internet, and then it goes wherever you set it up to go around the world and talk to people. And she was able to talk to people in Australia, South Africa, Japan, just with a little handheld. And the way that worked is, on my computer, I bought it's called a little dongle that is a UHF transmitter receiver, low power. And I plug that in, and there's software that the handheld on UHF or VHF sends a signal to this little dongle. The software on the computer does the conversion to transmit it on the internet. It ends up at the destination and is retransmitted on a repeater in Japan or whatever. And so the ham there is listening to that repeater. You know, it's like voice over internet phone. It's exactly the same thing. Now, the issue with that, in my opinion, I think most of our group's opinion, is that's fun to do, but it's not something you would want to spend time getting prepared for emergencies because that internet could be down and then you're dead. So that's one of our evaluation criteria. Are we considering doing something for emergency communication if it needs the power grid, the internet, or cell phones? We don't use it. And that's just kind of a personal
Yeah,
preference.
that's not gonna help us in case of emergency.
No,
The internet's down.
And the phones, they knock down all the communications, so.
right? Well, I know when 9/11 happened, my daughter was working for the, well, she still does. She worked for the Patent and Trade Office in Crystal City, which is right by the Pentagon. And she actually watched the Pentagon burn from her office. And before the, after the first plane hit, before the second one, I'd talked to her. And then after that, I wasn't able to get in touch with her for about 7 hours later because the phone systems were just so jammed up. And she and another friend decided what they would do. They sat in a bar there in the building where their office was, and they just drank and had a good time till traffic cleared out. Then they went home. So maybe we did raise her right. I don't know. But that's how a repeater works, and that's why we're able to use our little handhelds here to cover all of Treasure Lake, the surrounding area, um, and why if you put enough money into it, actually, I bet a repeater to duplicate that repeater, we spent about $1,000 on our maybe $1,200 on our repeater setup. Probably one that does what the one on Rockton Mountain does would probably be 10 times that. So,
Especially count the tower.
oh yeah, the tower, the amplifier. I mean, everything's scaled up. So
The tower is 150 feet higher, so it's pretty expensive.
that's why it's so important to really define the problem you're wanting to solve, so you don't overspend it.
Yeah.
To me, that's what good engineering is. Just enough to get the job done. Maybe a little more, but not much. And then in terms of emergency operation in this area and around the country, there are two primary organizations. Amateur Radio Emergency Service, it's referred to as ARES, and it's a group of hams, and they serve the Red Cross, the Salvation Army, National Weather Service, and others. And what they do is they prepare and train so that they could go into the Red Cross facility during an emergency and send information from Red Cross to Red Cross station or wherever it needs to go. RACES is another ham group, Radio Amateur Civil Emergency Services, and it's sponsored primarily by FEMA, Federal Emergency Management Agency. And the group here is primarily sponsored by PEMA, Pennsylvania Emergency Management Agency, and they transmit and pass traffic related to the state emergency information. So what we've done, we've got a handle. We know how all these work and where the frequencies are, so that we can monitor those kind of things and know what's going on. Our ham group's a little different in that the served agency, like the served agencies here, are these organizations. The RACES, the served agency, is FEMA and PEMA. Here, our served agency, we consider our community. We want to be able to get information in and out of here if everything's down. We had didn't sell many of them. I think we sold about 20. We took radios similar to that. They were UHF only, and I programmed them so that it could receive our repeater, but you couldn't transmit. And we sold those to non-hams that wanted to be able to monitor our repeater.
Yeah.
And I think we sold them for $20 and they cost us $10, so we made a little money.
Yeah.
But we didn't have a lot of interest. To sell 20, that just
2,000 homes out here doesn't.
yeah.
1 in 100 like that.
I'm a salesman. Next time that you
Yeah, there
I'll
you
get them all one up.
go Russian for
go. There you go. So we consider our community our served agency, to use the same jargon as the other two groups, and we're involved with these. I mean, I attend, for example, there's a net which happens actually for Aries. It's a health and wellness net Monday through Friday, and then on Saturday they have a regular check-in, but it's hams all over Western Pennsylvania check in so they can make sure that their equipment's communicating across the state. And it's good to be able to check your equipment and make sure it's operating, because if you don't do it, something's going to go wrong, and then there's an emergency, and then you find out your antenna's laying on the ground. Well, that's not the time you want to work on an antenna. So the way our group works is that we have kind of a hierarchy of radios, and it's all centered around our repeater. This is the repeater that's in the church, and what we use the repeater to do is with the hams that have local handheld and mobile base stations, they can all communicate. The hams or the non-hams with the receive only radios can hear what's going on. They can hear what we're talking about. And then there are some of us, I don't know, we probably got 10, 12 people that have HF stations that can do the regional, state, and nationwide communication. They also have the VHF, UHF radios. So things they hear going on outside across the country or across the state can be relayed to everybody here. So that's how information would transfer in and out of here. Probably more of it coming in than going out, because if we had a dire situation, we would be able to contact the Pima people or the Aries people to let them know, we got a problem here, need help or whatever. And this is the way it would go, because we really can't get too far out with this handheld stuff, the VHF, UHF. So we have to link the people that can get out with the repeater so that everybody can communicate. So that's kind of a general.
But a kid would, they're in the middle on the top of Sky County.
Yeah, I think that's probably a 590, because that's what I've got. I had that picture handy.
The orange display.
Yeah. I think it's a 590. This is 7300. I don't know what this is. It's probably I don't know. It's something, but it's more the concept.
Mm-hmm.
Now, we all have different levels of readiness. For the HF radios, I've got my main base station. You saw the picture of. I've got an HF station that we use for POTA. And then I've got another HF station as another backup. It's all battery powered, we're ready.
In that HF station here.
Yeah, we got one here too.
Oh, really? I just need to get my call sign so that I'm able to
Yeah.